One of my favorite questions that I get asked is, how do I design boundaries that don't need to change frequently? So we're thinking about team design here, and I like to use team topologies to think about this. And when we're looking at this problem, it's basically, some teams need to change their boundaries, or they need to change and force a change onto other teams, or other teams need to change to keep up with another team. This often can be something like a platform team that owns a service, and everyone in the company needs to upgrade to the latest version of that. But it can actually come from anywhere. It can come from a non-platform team who owns a piece of data somewhere, and that data contract is central to everybody's concept of what's going on in the business. That can also create this cascading change throughout the whole company of everyone needs to get behind this major, very high cost initiative. And actually, we can design that problem out of our system, or at least minimize it, contain it, and predict it in a much more accurate way with a little bit of team design, thanks to team topologies. Plus, what I like to use as my mental model for this, the package principles, which come out of software architecture. So let's take a look at this really quickly. So if you remember in a previous video, I talked about how do you change the interaction modes of teams very quickly, right now, next, and later. And what can you do to make the change of now, next, later to be measured in days or weeks instead of quarters or years between interaction mode changes, right? So when we look at that, I think one of the interesting things here, we discovered, for instance, keeping groups aligned allows them to change modes really quickly, and we want to have interaction modes between groups designed on things that don't change quickly. So what we're talking about is, how do you design boundaries that don't need to change so quickly, right? So how do we design this problem out of our system in the first place? And what I like to think about here is, this kind of continuum here of abstract models and business details, right? So more abstract models down, and then more business details upwards. And when we think about this, it's, if you ever owned a DVD player, which, I remember VCR, but some of you might only remember DVD players. But the idea was, you had a physical real world device, and you would plug in a DVD into that and play a video using this. Now, the abstract machinery for a DVD player is not going to change very frequently, right? It's actually over 25 years. Actually, I don't even remember how long, but it's decades now almost of how long we've had DVD technology, and we still sell them in stores, right? And they still work. And videos that came out using, very modern technology to film them had a very stable interface from something that did not need to change over the course of decades. And that is because we did not go out and sell individual DVD players with the movies programmed into them, right? There were, at this time, around DVD players coming out, MP3 players also came out, and you could buy children's toys with 2 or 3 popular songs pre-programmed into them. These were not separated from the details, right? The actual content that you wanted to run. This was baked into the actual thing itself, right? There was no separation between the detail of the content you wanted to enjoy and the machinery that would play that thing. So this is a way to think about this, right? So the abstract model is, it doesn't know what you're going to play. It understands how to convert a codec into a visual, but it doesn't know you're watching Shrek or Star Wars or Oppenheimer or whatever movie you want to watch. It just knows, how to interpret a shared agreement, right? And up here, it doesn't know how to do all the things a DVD player does. It's simply delivering that content to a DVD, right? So this is the way we need to think about this, is as you go deeper and deeper down the dependency chain of, one group depends on another group, depends on, another group of teams, the one at the bottom needs to, so like, let's say up above is a group of teams and down below is a group of teams. The bottom team needs to change less frequently, which means The business details, and business details change by the hour in some cases, right? So, what are we building? What does the customer want? What are the validation rules? How does all that stuff work? That stuff is going to change lightning fast. And then down here at the bottom, we have, the abstract models, not what are we validating, but what is the engine for validation? What is the abstract primitives that we don't know how they're being used, but we're offering them up. All right. And then if you go a layer deeper, we're not even talking about the machinery for that. We're talking about, the conventions for validation, right? What we need to think about here is those abstract things, the reasons to change them ought to be, and when, you reach this ideal state, are slower than the business details, which are changing very, very rapidly. And then the abstract details change nice and slowly. And this means when you design your groups, not only internally to your individual teams, right? So you want, first of all, the reason to change this interaction, right? Like inside of a group of teams, that should be slow. And that means Stream F needs to provide an abstraction, not the details for Team C, right? So if Team C is, a Shrek 2 DVD, you can't take, minutes 20 from 28 out of Teams, Stream C and bake them into Stream F for them to do. You have to instead expose an abstraction that makes it simpler for them to reach their mission, right? This will introduce fewer reasons for you to change the interaction mode. Now, it could be one day everyone says, we're going to Blu-ray, we're going to streaming platforms, we're doing everything, and that's okay. It's just, you're moving on to another long-term stable piece of technology, right? So the reasons to change are less frequent. So inside of a team, put your abstractions at the bottom of your dependency tree as much as possible. And then your external teams, right? So this is really important to get right because remember, in a previous video, we looked at this, right? The crossing the group of teams boundary, people, process, product, and tech will be moving in a different direction between the groups. You are going to want to make sure that is very stable and very long-term running, right? So do not take the business details and put them into your abstractions. And your team should be offering a way to make the business easier, make that mission accomplishable without having to do the whole thing for them. And you don't take away the details of what that is, right? You still allow it to be a self-service interface. And I think a lot of teams, let's make that very specific. Let's think about our common, a lot of people still to this day think a platform means my DevOps team. And a lot of people think DevOps means people who look after cloud infrastructure. And that's not what either of those words mean, but this is what a lot of people think they mean. And this ends up in a state where, this platform team is responsible for the deployment, monitoring, hosting, and maintaining of all the software that Stream C develops and writes and, produces. Actually, in that reality, you're actually handing over the running and maintaining and monitoring of software to another team, right? That stream did not really own anything end to end. They were a handover in a waterfall process. But that's a different topic. But, in that environment, platform A is always needing to change based on the details of what Stream C provides. It's a much better method if, platform A says, I'm going to expose to you a simplified way for you to build, run, monitor, and maintain your own software. In our environment, I've removed, 500 variables and I've simplified the thing so you don't have to think about all of these different things, and you can get going with something that's aligned with the way we're going in the company, right? So the amount of complexity Stream C has to absorb to do that work is very small. However, it means Stream D can be long-term stable and not have to think about what Stream C is doing with that technology. So I think that's the important thing there to think about, right? How do I design boundaries that don't need to change frequently, right? Keep that separation in mind, right? Details at the top, abstractions at the bottom, right? That's the key guidance there.